Okay, good morning everyone. So today's topic is basically the round robin scheduling. So this is the operating system, basic, very classical and a very important topic for the operating system subject. So what is the round robin scheduling? Before the round robin scheduling, we have to know the two terms. Is called as a preemptive scheduling, and another one is the non-preemptive scheduling. Okay, first I want to tell that is the round robin scheduling is basically the preemptive scheduling. Okay, with the help of example we will understand that is what is the preemptive scheduling. See, so I am writing or I am drawing a small box. This one is called as a CPU, and here I am giving the input and here I am taking the output. Okay, so from here I am giving some jobs. So job J1, J2 and the J3, and this in that way I will give up to n times job. Okay, and the several and the same, that is the output 1, output 2, and I will get the output 3. Okay, so for the job 1, if it requires 4 amount of time, job 2 say 3 amount of time, and the job 3 required 5 amount of time. Okay, so what is the preemptive and what is the non-preemptive scheduling? So for the non-preemptive scheduling, if I schedule the job 1 to the CPU, then whole the process of the job will be finished within the 4 amount of time. Okay, that means the entire process will be finished within the 4 amount of time. Same as like that for the job 2, if I schedule the job 2 into the CPU, it requires basically 3 amount of time, so whole the process of the job 2 will finish within the 3 amount of time. Okay, and for the job 3, if I assign the job 3 to the CPU, it requires 5 amount of time. That means the CPU will take 5 amount of time to execute the whole process. So this one is called as a non-preemptive scheduling. So if I tell the preemptive scheduling, then what is the difference? The difference is that I will not give the entire job 1, job 2, job 3 at the end. That means I will give 2 amount of time to each and every one. 2 amount of time to each and every one. That means if the job J1 requires 2 amount of time, so out of 4 it will be executed only 2 and the 2 left. Same as like that for the job 2, if it requires 3 amount of time, so I will schedule to the CPU to that 2 amount of time, and it basically remaining, that is the 1 amount of time. Same as like for the job 3, if I place to the CPU to the job 3, it requires 5 amount of time, but I am scheduling 2 amount of time, so remaining 3 amount of time. That means the parallel processing we are basically doing with the jobs. Okay, so I am giving the parallel time to each and every jobs, and we are getting the output at the very end. Okay, so if the job 1 requires the remaining 2 amount of time, so when it will come to the CPU again, that means when all the processes are basically touched, at the end the job 1 will come at the very first to do the remaining work. Okay, so this one is called as a preemptive scheduling. So I have written a small problem. Here you can see I have written a small problem. So this problem is basically very important for the any kind of examination. It may be GATE, it may be NET, it may be SET, or it may be ISRO, or wherever you can go. This problem is very much important. Okay, so now you just give the concentration to this problem. So here I have written that is the round robin scheduling, and as I have already told, this one is the preemptive scheduling. So this one is the preemptive scheduling. Okay, so that means I will give 2 amount of time to each and every job. Okay, so here I am considering time quantum as 2. Okay, I am considering time quantum as 2. Okay, see, so as this one is the round robin scheduling, so as for the previous examples, so we basically require a Gantt chart to solve this problem. So I am drawing this Gantt chart here. Okay, so Gantt and the chart. Okay, and it's not possible to solve using only the Gantt chart. So again I have to use another data structure is called as a queue. Okay, another data structure is called as a queue. Okay, next, see, so I am starting my problem. This one is the 0. Okay, 0 arrival time. Now see, in the 0 arrival time, how many processes are active? See, only the process P1 is active. At the arrival time 0, only the process P1 is active. So I will schedule the process P1, and I will give the 2 amount of time. Okay, so as here 2 amount of time is given. Okay, so my deadline is 2. So within the 2, I have to finish the job. Okay, so 4 minus 2, it's basically remaining 2 amount of time. Okay, see, now the 2, how within the 2 amount of time, how many processes are basically active? So here you can see 1, 2 and the 3, total 3 processes are basically active. Okay, now I will going to write, that is the P2 and the P3. Okay, P2 and the P3. Okay, now see, so P2 and the P3, so I am removing the P from the queue, and I will be assign the P2 to the Gantt chart, and I will add another time quantum, so 4. Okay, now you please tell, P1 is finished or not? No, so I have to write after the queue. Okay, next, 4 amount of time, within 4 amount of time, how many processors are active? Total, see the arrival time, 0, 1, 2, 3, 4. So 4, total 5 processors are basically active, 1, 2, 3, 4, 5. So 3 and the 1 is already there, so I have to write only process P5. Okay, process P5 I have to write, within the, sorry, process P4 and the process P5. Okay, process P4 and the process P5. Now see, now you please tell, P2 is finished or not? No, P2 is not finished, so I have to write at the very end. I have to write it at the very end. Okay, next scheduled process is P3, so I have to write the P3 here. Okay, so how much time required? So for the P3 the time is basically 2, so 4 plus 2 is basically 6. Again, P2 is scheduled, yes, so 5 minus 2 is basically 3, and 2 minus 2 is basically 0. The process P3 is basically finished. Process P3 is basically finished. Now you please tell, how many processors are active? Now process P6 is active. Okay, process P6 is active. So P6, now you please tell, P3 is finished or not? No, yes, P3 is finished, so no need to write at the very end. Now I am deleting P1 and I am scheduling P1 after that. So 6 plus 2 is basically 8. 6 plus 2 is basically 8, and I am removing 2 to 0. Okay, so process P1 also finished. Okay, now the process P4, I am removing process P4. So P4 and the P4 required only 1. So 8 plus 1 is basically 9, and also the P4 finished. Okay, so process P1, P3 and the P4 finished. Now I will be scheduled the P5. Okay, P5, so P5 is required how much? 9 plus 2 is basically 11, and I am subtracting it from the 2. So 6 minus 2 is basically 4. 4 amount of time is basically remaining. Okay, now see, 6 amount of time is basically P4 finished. Okay, now P5 finished or not? No, P5 not finished, still 4 amount of time is remaining, so I have to write at the very end. Okay, next the P2 I am deleting P2, and I will be assigned it to the Gantt chart. So what is the amount of the P2 is 3. So 3 minus 2 it's basically 1. So the 11 plus 2 it's basically what? 13. Okay, now so again the P2 is not finished, so I have to write at the very end. Okay, now P6, and how much amount of time is required? 3. So 2 minus 3 is basically 1 remaining. Okay, so P6 not finished, I have to write at the very end. Okay, now P6 done. Now 13 plus 2 it's basically 15. Okay, now P5 how much required? P6 finished? No, P5 how much? P5 required only 1. P5 required only P5 required only 4. Okay, so 15 plus 2 it's basically 17. Okay, now I am subtracting it by 2. Okay, now P2, I am removing P2 here, P2, and the P2 is basically required 1. So 17 plus 1 18. Okay, now the next job is basically what? So P5 is not finished, still 2 amount of time is remaining. So after the P2 P6 is there. So after the P2 P6 is there. So P6 it's basically 18 plus 1 is the 19, and next 19 plus P5, 19 plus 2 it's basically 21. Okay, so 21. So my Gantt chart finished. Now I will calculate what? I will calculate. So what are the values? 4, 5, 2, 1, 6, 3. Okay, 4, 5, 2, 1, 6, 3. Okay, so next I will calculate the completion time, turnaround time, and the waiting time. Okay, now see. Okay, so completion time of the P1 to start from the very right to the left. Okay, start from the P1. So here it is 8. So here you just write 8. P2 18. P3 here it is. So here it is 6 and here it is 18. P4 here it is 9 and P6, where it is P6, it's 19. Okay, now turnaround time, it's basically the difference between completion time and the arrival time. Okay, so 8 minus 1, it's 8 minus 0, it's basically 8 minus 1, it's basically 17, 6 minus 3, it's basically 6 minus 2, it's basically 4. So 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5. I have done something wrong. So here it is completion time, turnaround time. Okay, 4 completion time of the P1, where it is 8. Completion time of the P2 18. P3 6. P4 9. P5 is the 21 and the P6 it's basically 19. Okay, so turnaround time 8 minus 0, it's basically 8. 18 minus 1, it's basically 17. 6 minus 2, it's basically 4. 9 minus 3 is basically 6. 21 minus 4, what it is? 17. Okay, 19 minus 6, it's basically 13. And waiting time is turnaround time minus burst time. So 8 minus 4, it's basically 4. 17 minus 5, 12. 4 minus 2, 2. 6 minus 1, 5. 17 minus 6, 11. 13 minus 3, 10. Okay, done. Next, what you have to calculate? You have to calculate the average of completion time. So just do the sum of completion time. Okay, just do the sum of turnaround time and just do the sum of waiting time. Okay, now how many processes are there? You have to divide the number of processes. So total 6 processes are there. So 6 and the 6. Whatever you will get the sum, basically you have to divide by 6. Whatever you will get at the sum of the completion time, you have to divide it by the 6, and same as like for the whatever you will get in the waiting time, you have to divide by 6. So after that, all these values, that means this one and this one, whatever you will get, it's basically the average completion time, turnaround time and the waiting time. Okay, thank you.